In previous class, we discussed about the forced response of RC circuit. Now we'll try to solve two more problems. So let us assume that we have some circuit like this. So this is 2 farad and this is 3 ohm, 6 ohm, this is 24 volts and this is 60 volts. Okay. So we have these are switch positions. It is A and this is B, right? The switch is connected here. At t equal to 0. Right. So initially the switch is connected at t equal to 0. The switch is connected at t equal to 0. Means initially the switch is connected at point A. So now at t equal to 0, the switch is moved and it is connected to point B. Right? So that is its meaning. So from minus infinite to 0, the switch is at A. From 0 onwards, the switch is connected to B. Right? So that is its meaning. So first thing is what we have to do is we need to obtain the initial conditions. We need to obtain the initial conditions for t less than 0. The circuit will be something like this. The switch is connected at A. So that means, so you have like this. And here this capacitor. So this is voltage across capacitor. So we need to find the voltage across capacitor t greater than or equal to 0. So this is, if you assume this is V, so this is 60 volts, this is 6 ohm, and this is 3 ohm, this is 2 farad, right? Since the capacitor is open circuited, the voltage across the capacitor is equal to the voltage across this 3 ohm resistor, So if we calculate, if you assume that the initial voltage is V naught, in other words, V of 0 equal to V naught. So what is its voltage?
20 volts.
3 by 3 plus 6 into 60. So this is 20 volts. Good. So this is 20 volts. So this is the initial condition for t greater than or equal to 0. For t greater than or equal to 0, the switch is moved to position B. So therefore, the circuit will be like this. All right. So now it is 24 volts, 6 ohm now, and this is 3 ohm, and we have 2 farad here. Right. So this is voltage across capacitor. Right. So for these things, you require two things. So one is V infinite, and another one is time constant tau. So that we can substitute in the formula. Right. So how to calculate? So V infinite. What is V infinite? So open circuit voltage across the
8 volts.
capacitor. Right. So now this capacitor is open circuited. So this will be 3 by 3 plus 6 into 24. So how much it is? 8 volts. Again, voltage division. So how to calculate the tau value? As we already discussed that So when you have a voltage source, we need to short circuit that voltage source. So short circuit this voltage source and this one. So we have a capacitor here. So this circuit is to calculate the tau. So this is 6 ohm and this 3 ohm and this is 2 farad. So tau is R equivalent into C. So what is 6,3? If you 6,3 are in parallel, so what is this resultant resistance is?
2 ohms.
2 ohm, right? So 2 into 2. So this is 4 second. So therefore, so we arrived everything, right? So what is the solution? So V of t equal to, right? So first thing is V infinite, so that is 8 plus V of 0, so that is 20 minus 8 into e to the power of minus t by tau. So what is t by tau? Minus t by 4. So this is its value. So this is equal to 8 plus 12 into e to the power of minus 0.25 t volts. So that is the voltage across capacitor. So that is the voltage across capacitor. So for example, if someone asks you about, right, so instead of directly also calculate current in the capacitor for t greater than or equal to 0. So this is the current in the capacitor. So how to solve this? You know voltage, right? So how to solve the, so how to obtain the current? So that means I of t equal to, so if you know the voltage, the capacitor current will be C into dV of t by dt. So differentiate this one. So differentiate this one and multiply with 2. So that means 2 into 12, right? I think into minus 1 by 4 e to the power of minus 0.25 t. Is this correct?
Sir.
That is the differentiation, right? So how much it will be? I think minus 6 into e to the power of minus 0.25 into t. So this is the current or the charging current through capacitor. So this is the charging current through the capacitor. Clear? So this is how we will solve when the switch is initially at position, some position. So that we'll use it to calculate the, what we say, that is used to calculate the initial conditions. So next step is we need to calculate V infinite and the time constant tau by short circuiting the voltage sources. And if you have a current source, you need to open circuit that current source. Right. So next we'll try to solve some other problem. This is relevant to inductor. So we are not discussing this, no? Just remove this one. Actually, that problem is related to RL circuit. Okay. So that problem is related to RL circuit. So we'll discuss one more one. This is 3 microfarad, and this 10 kilo ohm resistor is there. Again, you have 40 kilo ohm resistor is there. And we have 20 kilo ohm resistor is there. And this is 30 U of t. So is given 30 into U of t. And initial voltage is also given. So this is the voltage across capacitor. So V of 0. So this is given as 5 volts. So this is the problem. So you might have studied what is the meaning of this U of t. You might have studied singularity functions, right? Have you studied that?
Unit step function.
Singularity function. So this is singularity function, right? So this is also known as switching function. So this U of t is known as singularity function, or also known as switching function, right? Right. So this is to identify, so when the circuit is when the circuit is continuous and when it is discontinuous, right? So that means we are representing the switch here. So right. So we have one side. So this is U of t here. So this is time t, and this is 0. Right. So how this U of t is defined? So how this U of t is defined? It's something like this. If U of t equal to 0 for t less than 0, so which is equal to 1 for t greater than or equal to 0. Understood? So U of t equal to 0 for t less than 0 and equal to 1 for t greater than 1. So how to represent this one? So here its value is 0, right? So now its value is 1. So it will be like this. So it will be like this. All right. So here, if nothing is mentioned that, so this is the definition of a singularity function. So this is the definition of singularity function. So meaning is 30 into E of t, right? So what is its meaning? What is the meaning of this 30 into E of t? So before t less than 0, so its value is 30 into E of t. So E of t is 0. So that means 0 for less than 0, t less than 0, right? And its value equal to 30 for t greater than or equal to 0. So here, so instead of representing a switch here, for example, we have switch here. This entire thing can be represented like this. So this is 30 into U of t. So if you assume that the switch is closed at t equal to 0. All right. So meaning is, so its value equal to 30 for t greater than or equal to 0. It is 0 for t less than 0. All right. So this is how we will represent the switches or switching functions in singularity functions. This is known as singularity functions. You might have studied in mathematics course. It is not studied. You'll study maybe in next semester or this semester only, right? So this is a general thing. So what about when the switch is happening at 2 seconds or when the switch is happening at -2 seconds? So in that case, so how exactly you will represent that, right? So here, so let us assume that, so this is the function. So this is 0 here, and we have time t, and this is u of t. All right. So we have, right. So now assume that, so this is the function. So this is how this u of t is defined. So instead of the switch is operating at t equal to 0 seconds, so now the switch is operated at t0 second. So now the switch is operated at t0 second. So how to represent this one? So this can be represented as u into t minus t0, u into, so that is unit singularity function. So u into t minus t0, so which is equal to 0 for t less than t0. Agree?
Yes, sir.
Which is equal to 1 for t greater than or equal to t0. Right? So this is how it will represent u into t minus t0. Similarly, there is another option. So this is t here. So now it is advanced. So now it is t0, and here it is u of t. So its value is 1 here. So how to represent this one? So this can be represented as u into t plus t0, t plus t0. So this will be minus t0, right? So this is equal to 0 for t less than minus t0, equal to 1 for t greater than or equal to minus t0. All right.
Yes, sir.
Okay. Right. So let us conclude this one. If u of t is there, so that means switch is closed at t equal to 0. If u of t minus, for example, 2 is there, so this switch is closed at t equal to 2 seconds. Right. At u equal to 2 plus t is there, for example. So the switch is closed at t equal to minus 2 seconds. So that is its meaning. Understood? Understood?
Yes, sir.
Right. So this entire thing is, right. So this is entire thing. So u of t and all these things. So these entire things are known as unit step functions. So this is unit step functions. General name for this one is unit step function. So why it is unit step function? Its magnitude is 1, right? And it is acting as a step, right? This is one step, right? So that's why it is known as unit step function. Okay. So more details about this one. So you will learn in the control subject syllabus. So that may be in 3.1 or 3.2. Right. So right now this information is enough. So this is known as unit step functions, or also known as U of t. So there is another name for this one is the singularity function, or switching function, or switching function. So ultimate objective is to represent the switching, right? Ultimate objective is to represent the switching. So that is the objective of this. All right. So now we have this problem, right? So what is the meaning of this one? So I will rewrite this problem. So this is 3 microfarad and this is 10K and this is 40K and this is 20K and this is 30 U of t, right? So initial voltage is given. So initial voltage across the capacitor is given. So V of 0 equal to 0, 5 volts, right? Okay. So meaning is at t equal to 0, so this value is 0. So for t greater than 0, so this is the circuit, right? So this is the circuit for t greater than 0. So now this value will become 30 volts. So this will become 30 volts, right? So from this, calculate its final value. So what is the final voltage across this 3 ohm resistor? What is the final voltage across this 3 ohm resistor since it is open circuit, right?
20 volts.
So now this one will be the voltage. So now V of infinite. So what is V of infinite? 40K divided by 20K plus 40K into 30. Agree? How much it is?
20 volts.
20 volts, right? So this will be 20 volts. So what is R equivalent into C? So that is time constant. What is R equivalent into C? As we have seen that, so this will be the, right? So this is short circuited, right? Now this will be short circuited 40 into 20 ohm. So that will comes in parallel, right? That will comes in parallel. And so which is in series with 10K, right? So that is 10 plus 40 and
70 by 3.
20. So these are in parallel. So this entire thing we have K here.
70 by 3, sir. 70 by
This
3
is K.
part.
This is also K. This is also K, right? Into 3 ohm. What you are saying? This is correct only, right?
Yes, sir.
Okay. So what is that answer? I think this is this is 40, 40, I think 70 by 3K, right?
Yes, sir.
Into 3 microfarad. So how much it is? I think
7 millis. 7
0
millis.
0.07
0.07 seconds.
seconds.
Okay. So now V of t. So final value is 20 plus initial value is 5, right? 5 minus 20. So that will be minus 15. Agree? Into e to the power of minus t by 0.07 volts. So this will be the answer for this question. Right. So try solving these problems. So calculate so V of t for t greater than or equal to 0. there is another one. Let's calculate. So V of t, again for t greater than or equal to 0. So there is another one. So we have dependent source here. So this is 50 ohm, and this is 30 ohm, and this is 0.5 I, and this is 3 farad. This is I, okay, and this is 40 ohm, and this is open at t equal to 0. The switch is open at t equal to 0, and here you have 80 volts. So try solving these problems. Okay, so these two are easy, right? And I think I have answers. Okay, answers are, just try these things. Answer for these two I have. I will provide that.
Sir, element values in second problem.
Hmm.
Values of the elements in second problem. In second
No, no,
circuit.
wait, 1 second. 1 second, I will provide. This is 2 farad, and this is 12 volts, and this is 4 ohm, and this is 2 ampere. Okay. And its answer is 12 minus 8 into e to the power of minus tau by 6. And this one is 4 minus 16 into e to the power of minus 5 by 8 t. Just check these things. Okay, it's not 100% correct. I don't have answer for this one. In next class, one of the class will solve. Try to solve this one. In one of the class, we'll solve this problem. Okay. So next we'll move to next topic, which is forced response of RL circuit. So far we covered the forced response of RC series circuit. So now we have RL series circuit. So let us assume that circuit is something like this. Right. So we have current here, L. So this is R, and we represented a Vs into U of t. Okay. I represented a, so this Vs into U of t. So this is inductor voltage VL. So inductor voltage VL. So inductor current is I. So I have initial conditions are given. I of 0 minus equal to I of 0 equal to I of 0 plus, so which is equal to I naught as usual, right? So here, so you are aware of this meaning, right? At Vs, for t less than or equal to 0, so this is open circuited, right? So this is open circuited and its value is 0, so that means it's open circuited. So there is no source here. And for t greater than or equal to 0, its value is equal to Vs. So that is clear to you, right? Okay.
Yes, sir.
So another thing is that, yes, another thing is that the inductor under steady state, the inductor acts as a short circuit, right? The inductor acts as a short circuit. So that means, so what is the final current here in this circuit? What is the final current in this circuit? This inductor acts as a short circuit, right? If this
Zero.
is short circuit, so what is the final current?
Vs by Vs into UT upon R.
Vs by
R.
what is Vs by R, right? So that final current is Vs by R. Right. So we developed one formula, right? So we developed one formula for capacitor voltage, right? Similar ways, in similar way, so we can write the inductor current, so which is equal to, so what is the inductor current? So what is the first one is, it's infinite, agree, plus I of 0 minus I infinite into e to the power of minus t by tau. So this is the formula, right? If you write the same formula in terms of, or if you apply the same formula for inductor current, so this is the one, right? Agree? Agree?
Yes, sir.
Okay. So let us substitute this one is Vs by R plus this is I naught minus Vs by R into e to the power of minus t by tau. So this tau equal to again, so this is L by R here, right? For RC circuit, the tau is L by R. So let us check this one, so whether our assumption is correct or not, right? So our assumption is correct or not, right? So now, so how to solve this one? So here the current is given, right? So now apply KVL here. So here Vs equal to R into I plus L into di by dt. This is the one, right? So our objective is to separate the di terms and dt terms one side, right? So if you rewrite this one, so di by Vs minus Ri, which is equal to dt by L. Agree? Is this correct? Right?
Sir.
If this is di, it should be something like this I minus some format, right? It's supposed to be I minus some format. So this how we followed, right? Okay. So now rearrange this one. It should be some di minus I minus something, some xyz, right? So if you rewrite this one, so it will be like this di, right? If you divide this one, it will be I minus Vs by R equal to minus R by L into dt. Just check this one, so whether this is correct or right or wrong. I just divided this one, so this
Correct,
denominator with R only. I divided with R, in other words, I multiplied with R, and I just same thing, right? So multiply with R minus R, in other words, multiply with minus R. So this is the one you obtained, right? Agree? Is this correct?
Yes, sir.
Okay. So now, what is the next step? Integrate this one. Integrate is in our required format di by I minus something, right? This is the format ultimately. So we need to achieve, right? Di terms on one side, dt terms on the other side. So if you integrate this one, So it is di by I minus Vs by R, so which is equal to minus of R by L into dt. This is 0 and this is t. What is this value? This is I naught and this is I of t, right? So can you directly tell me what is I of t?
Same formula as it is.
What is I of t? If you solve this one, so what you are getting? So it will be Vs by R plus I naught minus Vs by R into e to the power of minus t by L by R, right? So L by R is tau. Both are same.
Yes, sir.
Okay. So
Yes,
both
sir.
are same, right? So both will be same. Again, right. So what is its meaning is, if you draw a curve, again, I'll draw in the next page. So if you draw a curve, okay, so what is that solution? I of t equal to Vs by R plus I naught minus Vs by R into e to the power of minus t by tau or L by R, right? Okay, so here its initial value is I naught, right? Its initial value is I naught and it reaches its final value Vs by R. Again, here also two possibilities: if the initial value is greater than the final value or the initial value lesser than the final value. Okay. So now you have this I naught here. So we're drawing for the inductor current. So with respect to time t. So one chance is that, so it is like this. So here, what is this value? Vs by R, right? Agree? So this is one possibility. So there is another possibility is this one. So this is Vs by R. Understood? So there are two possibilities, right? Depending on the final value. So whether it's greater than that or lesser than that. Correct. Understood? If there is initial conditions are zero, if the initial conditions are zero, so it will start from origin and its value is Vs by R. If I not equal to 0 here. If I not equal to 0, so this is its value. So another graph, so which is the voltage across the inductor. So what is voltage across inductor V of t? So that's L into di by dt, right? If in this case, if you assume that I not equal to 0, so what is voltage across inductor? What is the voltage across inductor? If I not equal to 0, what is the voltage across inductor?
Yes, by R into e power
So
minus t.
what is, tell me what is this value? If I not equal to 0, so what is this value? If I
Yes, by
not
R
equal to
into
0, so it will
e.
be I of t equal to Vs by R into 1 minus e to the power of minus t by tau, right? Agree? So now V of t equal to L into di of t by dt. So what is this value? What is this value?
So Vs by tau R.
Vs
By
Vs
R.
by R.
Tau R. Tau,
What
sir.
is tau R? So
Yes,
it's
sir.
L into di by dt, right? If you carefully observe that, so that L and R get cancelled. Just check it out.
Yes, sir.
So what you left?
Vs only. Yes, yeah.
So Vs into e to the power of minus t by tau. Agree? So you'll get only Vs into e to the power of minus t by tau. Understood? So you'll get only Vs into e to the power of minus t by 2. So how exactly this will be? So its initial value is 0 and its final value is Vs. So that means its curve will come something like this. So this is Vs. This is 0. No, no, no. What is its initial value?
Vs.
Hmm?
Vs, sir.
Its initial value is Vs, right? So it will be like this. Okay. So this is Vs into e to the power of minus t by tau. So this value is Vs. Understood? So we applied the same principle here. We applied the same principle here. Again, so this can be written as two components, right? So this can be written into two components, right? So in one of the class we discussed one is the natural response and forced response. So this I of t, so this Vs minus R plus I naught minus Vs by R into e to the power of minus t by tau. So this can be written as Vs by R, right, into 1 minus e to the power of minus t by tau plus I naught into e to the power of minus t by tau. So what is this one? So this one is natural response and this is forced response and this one is final response or final response in other words. So natural response plus forced response, right? So generalization of this one for any circuit, so this will be so I infinite plus I of 0 minus I infinite into e to the power of minus t by tau. So this is its formula, right? So now we'll try solving one or two problems on this. Understood? So no need to remember every formula. So you need to just remember this formula. So that's sufficient for every case. So next we have, let's try to solve one problem. The switch is closed at t equal to 0. This is 3.5 Henry. This is 4 ohm. This is 12 ohm. And this is 4 ohm. And this is 2 ampere. So initially the switch is right? So initially the switch is open, right? So the switch is open, so that means for t less than or for t less than 0, the circuit will be something like this. So you have current source here, and this is the circuit is not there, so you have only one inductor is there. So this is the circuit, right? 2 ampere, this 4 ohm here, this is 4 ohm, so this 3.5 Henry. So under steady state, so this is short circuited, right? So now what is the current through this? What is the current here?
1 ampere, sir.
So it is only 1 ampere, right? So because both are 4 ohm resistor, so that means that is equally divided. So that means I naught equal to 1 ampere. So next draw for circuit for t greater than or equal to 0. So how the circuit will be? So now this resistor comes into the picture. Again, this is 3.5 Henry. This is 4 ohm. This is 12 ohm. And this is 4 ohm. And this is 2 amperes. So what is I infinite here? What is I infinite? So this will be
6 by
short circuit again, right? So this is short circuit again. So how to calculate I infinite?
First, resolve the 4 and 12 ohm resistor.
So these two in parallel, right? So what is the parallel one?
So 3 ohm resultant.
So this is 3 ohm, right? If these if these two are in parallel, so these two are in parallel, right? And this resultant is 3 ohm. So now the current is divided between this 3 ohm and 4 ohm. So what the formula is? 3 by 3 plus 4 into 2. Agree? That is how the current division is there, right? So 3 by 3 plus 4 into 2. So what is this value? 6 by 7?
Yes, sir.
6 by 7
0.8.
amperes.
Yes.
Right. So what is how to calculate tau? So which is R equivalent, no. L by R equivalent, which is L by R equivalent. How to calculate that? See, in one of the class we discussed that. In one of the class we discussed that. So whenever you have a current source, open circuit that, voltage source, short circuit that. So this is a current source, open circuit this one. So now you left with a resistor, another resistor which is in parallel, and you have another resistor, and you have this inductor, right? So what you will get if you deduce this circuit in this form,
7 ohm is R equivalent.
right? This is R equivalent, right? So what is R equivalent here? So this
7
is how
ohms.
much? This is 4, this is 12, and this is 4, right? So that means 7 ohm. So now what is this one? This is 3.5 by 7. How much it is? 1 by 2. So tau is 1 by 2 seconds. So what is the final answer? I of t. What is the final answer? I of t. Its initial value, so that is 6 by 7 plus, right? So 1, so final value 6 by 7, initial value 1 minus final value 6 by 7 again into e to the power of minus 0.5 means minus 2t. Agree? So that means 6 by 7 plus this is 1 by 7 into e to the power of minus 2t amperes. So this is the one. This is correct? Correct only, right?
Yes, sir.
So we'll try solving Another one. This particular switch is open at t equal to 0. So this switch is closed for a long time. This switch is closed for a long time and it is open at t equal to 0. Right. So this is the inductor current I. So calculate I of t for t greater than or equal to 0. The switch is closed for a long time and it is open at t equal to 0 seconds. Right. So what will be the circuit for t less than 0? So t less than 0. So the circuit will be right. So this, what is the fate of this switch? So this is closed, right? What is this I? What is this current I now? Tell me. So what is the value of that current I?
6 amperes.
6 amperes, right? So this is short circuited, and so here once it is, this is short circuited, so the current is directly flowing like this, right? That current is directly flow like this. Okay. So this I equal to 6 ampere, so which is equal to I naught. Understood?
Can you repeat this step, please?
So this inductor is short circuited, right? Agree?
Yes, sir.
Right. So now this is the current. So this current will start here. So as this is short circuit path, current will always choose the short circuit path, right? So that means it will flow like this. So this is also short circuit and it will end like this. So here there is no current that flow through this circuit. This 10 ohm resistor, the current is 0, right? So whatever the source is having, the same current is repeated, same current is circulated. So that's why this current is 6 amperes. Understood?
But it will not flow in
The
5
5 ohm
amperes.
resistor also
5
short
ohm.
circuited.
Why it will not flow? No, this is also short circuited here. So here this is short circuited, right? So here the 5 ohm current is also 0.
Okay.
Okay. Understood?
Yes.
Okay. So here resist current is always choose the lowest resistance path, right? So here the resistance is 0. So that means the current that flows through this one is 0.
Sir, how do you know, sir,
Yes, yes.
when it's a short circuit or no? How
No,
can we
no.
find, sir?
How can we find?
It's short circuit or not?
This is given, no? What it is given that the t equal to 0, the switch is open, right? So what is it meaning? T for t less than 0, the switch is closed, right? That is the meaning of that statement. So that means the switch is closed means that there is a direct line. And there is another thing is that the inductor is short circuit for, so when it is under steady state, the inductor is short circuited. So that is another statement. This is also short circuit. So this is also short circuit. Okay. That means the direct connection between these two terminals. So that's why the current will always choose the lowest resistance path. So therefore, this is the complete circuit, right? It will flow through this inductor and this one, and this is come to here. So there is no current here, and there is no current here. right? So this is the circuit for t greater than 0. So now for t, for t less than 0, so how this circuit will modify? So now this will be open circuited, right? Right. So now tell me what is I of infinite?
4
What
amps.
is I infinite? So again, this is
4
short
amperes.
circuited. So current is divided between, right? So 10 by 5 plus 10 into 6, 4 amperes. Okay. So what is time constant? L by R equivalent. What is, how to calculate R
0.1 second.
equivalent again?
0.1
So this
second.
is this inductor you have. And this current circuit, we already stated that. So this is open circuited, right? So that means we need to discard this current source. So you left with these two circuits only. This is 1.5 Henry and this is 5 ohm and this is 10 ohm. Okay. So what is L by R equivalent? It is 1.5 by
0.1 second.
15, right?
Yes, sir.
Yes.
I think this is 1 by 10 seconds. So what is the final solution I of t? What is I of t?
4 plus 2 into e power minus 10.
What is the 4 plus
2
6
into
minus of 6 minus 4, right? That is 2 into e to the power of minus 10t.
10t.
Correct?
Sir,
Yes.
sir, in that case, after short circuiting, 10 ohm resistor is also considered for current flowing for t greater than 0.
Yeah, this is the circuit, no? For t greater than 0.
Yes, sir.
This 10 ohm circuit we need to consider, right? So this circuit is different. So this is for t less than 0 and this is for t greater than 0. In t less than 0, there is no current through the 10 ohm resistor. So now the equations are changed, right? This is for t greater than 0. Now the current flowing through the 10 ohm resistor.
Yes, sir. Got it.
So this is 2 ampere. This is 12 ohm and this switch is open at t equal to 0 and you have 20 ohm. So this is 6 ohm and this is, I think this is visible, right? This 5 ohm resistor and you have this 0.5 Henry and here you have 20 volts. Right. So the question is to find out the voltage across the inductor. Voltage across the inductor. So you need to find the voltage across the inductor for t greater than 0. So value of V of t So try to solve this one. So here the answer I will provide. It is minus 4 into e to the power of minus 20 t. All right. So how to solve? So this kind of problems is right. So this is the circuit. So this is given, right? So here for t equal to 0, the switch is closed. So that means how this circuit will modify for t less than 0. So how exactly the circuit it look like? So you have a current source here. This is the circuit, right? So here you have 2 ampere. This is 12 ohm. This is 20 ohm. And this is 6 ohm. And this is half Henry. And this is 20 ohms. This is 5 ohm. All right. So our objective is to find out the inductor initial current, right? So this is the inductor initial current. This is I. So how to find this inductor initial current in this kind of complex circuits? How to find the inductor initial current in this type of complex circuits? What is the best way to find that? Right. If you assume that, so this is the ground terminal, right? If you assume that, so this is the ground. If you apply nodal voltage method, so from that, if you know this node voltage, right? So from this, if this will be short circuited, right? So this is short circuit. So SC means short circuit. So now, if you know this voltage, for example, if you assume this voltage is Vx, so what is I? Or in other words, what is I naught? This is I naught. What is I naught? If you know the voltage, what is the value of I naught? Will it be Vx by 6? Agree?
Yes, sir.
Yes.
Yes, sir.
So it is Vx by 6 amperes since the inductor is short circuited. So now our step is how to calculate the value of Vx. Right. So apply KCL at Vx. So apply KCL at Vx and tell me Vx node. What is the first one? If you assume all are uh, right, all are outgoing. So first one is minus right. So that means one side you have 2 amperes. So that is the incoming current. If this is outgoing, so this is also outgoing. So this is outgoing and this is also outgoing, right? So this is incoming, right? So 2 equal to, so what is this current? What is this current here? So Vx by 12, agree? plus Vx by 20 plus Vx by 6 plus Vx minus 20 by 5. So this is the 1. This is equal to, and both are same, right? So from this, what is the value of Vx?
Sir, 12, sir. 12 ohm. 12
What?
volts, sir.
Volts. So that means I naught equal to 2 amperes.
Sir.
So I naught value is 2 amperes, right? Agree? Understood? Right. So this circuit, how exactly this circuit is modified for t greater than 0. So how this circuit is modified? So this is open, right? So that means this entire thing is eliminated. So you left with this circuit. So now this is 20 ohm. This is 6 ohm. And this is 5 ohm. And this half Henry here. And this is 20 volts. Okay. Right. So now calculate. So this current. Calculate. So that particular current. So how to calculate? If you notice that this circuit can be rearranged something like this. Or you can directly calculate that current, right? So what is that value of that current? You assume that, so that is short circuited. If this is short circuited, okay, this is short circuited, what is the current? What is the resultant current? You find out what is the resultant current. What is this current I? Our objective is calculating I infinite, right? So now 20 and 6 ohm are in parallel along with this 5 ohm resistor. So along with that 5 ohm resistor. So what is the
Sir,
total current that is flowing?
Sir, 52 by 25.
22 by,
Sir, 52. Sir, R equivalent is 125 upon 30.
no, what is this current I am asking?
52 upon 30, 25. 52
52.
upon 25. I, capital I.
52 upon capital I.
No, sir. Capital I is 52 upon 25.
So this is 52 upon 25.
Yes,
Okay,
sir.
that's you are saying.
Yes, sir.
Okay, so this is equally divided between this 20 ohm and 6 ohm resistor, right? Agree? Understood? So this should be equally divided among, so this 20 ohm and this 6 ohm resistors. So that is the one, right? So this circuit can be redrawn something like this. You're confusing. So now this is 20 volts. So this is 5 ohms. And this will be 20 ohm. And this is 6 ohm. And this is 1.2 Henry, right? This is the one, right? If you carefully observe that, this is the circuit. Both are same. Let's check it out. Both are same only, right?
Yes, sir.
Okay. So now what you said that, so this current is 50, this one is 52 by 25 amperes. Okay. So this is equally shared among, so this is the current you required, right? This is the I infinite you require. So what is I infinite now? So tell me, so that's 20 by 26 into 52 by, what is that? 20, 25. So this is 1 and, so what is this value here? 40 by 25, 1.6. Is it 1.6?
Yes, sir.
1.6 amperes. Understood? So what is tau L by R equivalent, right? So how this circuit is modified? We calculate tau. That is short circuited. So this is inductor here. This half Henry, and this is 6 ohm, and this is 20 ohm, and this is 5 ohm, right? So tell me what is R equivalent? 50 and 4 are in parallel, right? I think the resultant is 4. 4 and 6, that is series. So that means R equivalent is 10 ohm. So that means 1 by 20 seconds. 1 by 20 seconds, right?
Yes, sir.
Okay. So this R equivalent is 4 plus 6, 10 ohm. So from this, what is the final one? So what we require is I of t. So that is initial value is 1.6 plus 2 minus, I think 2, right? 1.6 into e to the power of minus 20t. This is the one, right? So which is equal to 1.6 plus 0.4 into e to the power of minus 20t. But the question is voltage across the inductor V of t. So which is equal to L into di by dt. L into di by dt. So differentiate this one. So what you will get? 0.4 0.4 into 20, right?
So minus 4 into e raised to minus 20.
Minus 4 into e to the power of minus
Minus 20.
20t. This is the one. How we got minus 4 here? Okay, L value is 1 by 2. Okay, right. Yeah, correct. So this is how to solve in case of complex circuits. So we need to use node voltage method or loop current methods to obtain the equivalent values, right? Yeah. So if you have any questions, you can ask me. Otherwise, we'll stop here.